We ordered the materials, designed, manufactured, and installed everything. And not a single force majeure happened. When they see my set of drawings, they're just shocked and say, "We've never seen anything this detailed before." The workshop had a ton of questions and there were a lot of mistakes. I don't know how people do glazing without KM documentation. You'll end up buying something yourself, going somewhere, welding some kind of bracket. It's just chaos. Alright guys, hello everyone. Our previous video was about how to take measurements correctly. Now I've decided to share my experience and make a video on how to do design properly, what stages there are, what sections a project has, how to work correctly with a structural engineer, and so on. First of all, of course, you need to understand that design work is done by a structural engineer. You should either have one on your staff, or you can contact a design bureau, or you can find some engineers on an outsourcing basis. In other words, you need to find a structural engineer who is well versed in designing translucent structures. Let's say you have such a person. Next, you need to give them a technical assignment. The basis for the engineer is usually the project at the AR stage. And the more thoroughly thought out and detailed it is, the better. Good architects, some developers, and private clients usually have an AR stage project because this is essentially the base, the foundation on which the house itself is built. If you have an AER project, that's great. If there is no AER and no project documentation at all, then as mentioned in the previous video, you'll need 3D laser scanning of the point cloud, photos, videos from the site, and possibly some additional information or instructions for the engineer. And, importantly, there is an appendix to the contract called the product specification, which describes and illustrates the configuration of the products, specifying the hardware, the glass unit formula, the color, the system, and so on. In other words, everything should be described and detailed as thoroughly as possible. We pass this information on to the engineer and commission them to create the KM stage project. This is a project in which the engineer includes, well, the cover pages, of course, with some general descriptions. Then come the building elevations, where the windows are placed with height markers. Next are the floor plans, which are also very important for understanding where each product is located. After that, the products themselves are depicted, along with cross-sections of these products, both vertical and horizontal. And then on these sections, the nodes are marked. Next come the nodes. The nodes, accordingly, are also horizontal, bottom, side, and top. The nodes show accordingly the method used to fasten the product, the materials used for fastening, how the finishing is done. I don't know, how people manage to do glazing without KM documentation. I actually know companies that just work off measurement sheets. The measurer draws something and they make it. I know these companies, I know who works like that. It's terrible. They have tons of problems, tons of mistakes because nothing is thought through in as much detail as it should be. Then all of this arrives at the site. Our measurer took measurements as best as he could, as he understood, and production did what they could based on their own understanding and qualifications. The installers, when they get these measurement sheets, have no idea. There are no details, no nodes, nothing. Just install it somehow, no one knows how, nothing is thought out or drawn up. Where are the elevation marks? Where and what kind of installation materials to use? None of that is specified. You have to go buy something yourself, maybe weld some kind of bracket on your own. Basically, the whole process is just chaos. I don't know, I don't work like that. Accordingly, the KM project is a very important document. I personally check it myself. The joints in this project are a very important point. There's an album of standard joints that I developed. I can share it with you. In fact, right now I'm sharing as openly as possible with everyone. I try to help the market develop and adopt this to share some of my experience, So if you write to me in the comments, I can send you the album of standard joints that you can use. My designer uses these nodes as a foundation, as a base. But of course, every project is unique. There are joints that are constantly changing, and some things are being refined. We discuss some non-standard solutions together, but the foundation is already laid out in these standard joints. By the way, I'll send it to you. I might make some adjustments to it along the way. Yes, it might not be the most up-to-date version, of course, but you can use it as a base. Yes, that is, we constantly encounter various nuances and feedback from the installers, and we can slightly adjust our technical solutions, like replacing some fasteners with others and so on. These are already the finer points. I can't share all of this with you completely because it really needs to be looked at on a case-by-case basis. And besides, things are constantly changing for me as well. I'm developing, not standing still, but still, this is a certain foundation. That's it. So you definitely need to check the project after the designer because designers are also a kind of control point and they often make mistakes. Of course, there are some who are good. Like mine, they make fewer mistakes. There are others who are not as good, and accordingly, they can make more mistakes. That's it. You absolutely have to check their work. And this is an important point. Let's say you've given all this to the designer. There are several options. He can, for example, draw all these products himself from the notes, from the catalog, draw all these sections, but that's not really correct and not very convenient. That's why the designer should have a program. Either you or the designer should have it. You need to provide the software. The software should be optimal. Alutech is AluPro. Reiners uses RenoPro and Schuco uses Schucal. Accordingly, now almost all system providers have databases in the logical program, meaning it could be logical with databases from, say, Cial, Alumark, or any other profile. Nowadays, almost everyone has them. Don't be lazy, don't skimp on the money, get this software for yourself, install it, or provide it to your designer. This is a very important point because the designer, based on your contract and the architectural project, builds the products in the program. I also have a well-established symbiosis with my designer. I would specify requirements for him directly, such as which brackets to use, which connections between the transom and the mullion, whether to install a transom to mullion end cap or not, which covers to use where, which pressure plates to choose, which sashes we use, with rounding, without rounding, which glazing beads, which gaskets, and so on. There are many combinations in this program. You need to learn how to use this program. It allows you to do a lot of things. I'll explain which ones later. So accordingly, either the designer or you yourself or the designer or whoever built it, you must definitely check all of this, coordinate these sections with the client, choose the right mullion according to wind loads, correctly determine all the configurations, the integration of the products into the facade, and so on. Let's say you've done all that. From this program, you can take the product sections and export them to AutoCAD. That is, the sketches and sections are exported, and the designer takes the architectural drawings, the measurements, the sketches and sections of the products, combines all of this, and creates the KM project. They essentially integrate these sections into our openings and then add the details to these sections, such as how to attach the frame and so on. So that's how the process works. Next, for example, the KM is ready. You can order materials in advance even before the KM is finished. That's usually what I do. So we build it in the program, agree on the section with the client, and then order the material. At the same time, for example, it takes 2 months for Alutech to deliver. The openings might not even be ready yet. We're still drafting the project, waiting for the openings to be ready so we can take measurements. But our materials are already on their way, and that's important. That's why you can build all of this in AluPro. For example, there's a report called the Project Plan, which includes sketches of the products with cross sections. It's very convenient. I highly recommend it. You can get it approved by the clients before ordering the materials. Just the configuration of the products and the cross sections for now, without dimensions, using the design dimensions, because everything comes in standard lengths anyway. And even if the actual dimensions change a little and the cutting layout changes, it's not critical. Usually it doesn't have any impact. Of course, it might affect a specific profile bar and you might need to buy an extra one, but at least you'll already have the main materials. So accordingly, this program generates a request for Alutech or, well, for some other supplier. That is, a complete list of materials, which mullions, which transoms, which gaskets, and the quantities. In other words, it provides a material specification. This same program can also generate a request for insulated glass units. So you first build the product according to the design dimensions, then order the materials and hardware. Then accordingly, you create the KM project based on the actual dimensions. After that, the designer takes this KM and adjusts the product dimensions in the program according to the approved KM project. So now you have the exact products. Next, from this program, he exports the order for the insulating glass units. We have already entered the exact product and precise dimensions. At this point, there can no longer be any mistakes. The program generates the correct insulating glass units. The main thing is to enter the correct formulas, assign the right glass units where needed, calculate everything accordingly, and so on. The order for the glass units and the order for materials have already been made. And then, from this program, cutting optimization for the workshop, how to cut, and the assembly specification, how to assemble everything. You can even export files to send certain operations, like milling, directly to a CNC machine. In other words, this program offers a lot of different capabilities. We only export the KMD from this program, that is, how to assemble for frame products. So for example, for doors or windows on a mullion transom system, we only export the cutting optimization, because in principle you could export something like a KMD for the mullion transom system, but the mullion transom system isn't as well developed in this program. That is specifically the task from the workshop is there, but it's not as well thought out as it needs to be. That's why there's a next stage. The next stage after the KM project is, well, of course, there are material requests. The next stage is the KMD project stage. KMD is already the assignment for production, and the designer, I'm not sure how it works for you, but I'm telling you how it works for me. He accordingly creates the column and beam KMD system manually. We used to do it using a program. The workshop had a lot of questions and there were a lot of mistakes. And it's impossible there because the column and beam system often has all sorts of non-standard complex angular structural connections, various brackets, reinforced ones, different types of brackets, a bunch of different seals, some compensators. One type here, another type there, window integration in one place. Then we have sandwich panels, a certain type of glazing unit here, another type there. It's extremely difficult for the workshop to assemble all of this. And the workshop spends a lot of time manufacturing these products. And a lot of mistakes occur. That's why we make all our decisions to minimize the number of errors. So we decided to pay the designer. He develops the KMD stage project for the facade. These are actual products, numbered, showing exactly where each mullion goes. Then each mullion is drawn separately. Its cross-section is shown, indicating which bracket to attach where, at what distance from the edge of the mullion, which compensators to install, and where, which gaskets to use, and so on. So the workshop cuts everything according to the layout, and then they have clear instructions. For example, mullion number 1, and this is exactly how it needs to be assembled. They assemble it, attach everything, and set it aside. Mullion number 2, it needs to be done like this. They set it aside. Here's a specific transom. Certain milling needs to be done on it. Certain compensators and gaskets need to be installed, and notches need to be made like this. That's it. They finished it and set it aside. So they prepared these parts. Then this whole bundle was packed up and sent to the site. When the installers are assembling everything, the KMD also helps them because the mullions and transoms are numbered. They look at the KMD and understand there's a diagram of the product with numbers showing which mullion and which transom goes where. They can see everything, and just like that, they assemble everything according to the diagram, like in IKEA, you know? In other words, it's an instruction manual for the installer. So there are minimal mistakes, both in the workshop and during installation, and the whole process is easier. As for the frame products, doors, windows, sliding systems, or something like an accordion, the designer takes those from the program. So he does the manual shop drawings for the facade, plus all the frame elements come from the program. They just create an assembly specification there, and that's enough for the workshop. Cutting optimization and assembly specification. Well, in addition, we might provide some extra milling details like milling for the handle, or a hardware installation diagram if it's not from the program, but from a third party, or locks if they're not from the program, but ones we purchase separately, automatic, German, and so on. So everything extra that we add there, let's say anything external, we provide the necessary machining or milling instructions for it. Because you have to understand the workshop logic. To minimize mistakes, there's a saw operator who cuts according to the cutting plan. Next comes the machining operation. It's important to clearly understand how the product will be positioned on the machining center, how to process it for the lock, the handle, and other elements for the soft close mechanism, and where to mill for the hinges. In other words, they need to have clear instructions. This information is either taken from the catalog if it's a standard solution, or detailed drawings must be provided to the workshop so they can do it precisely. Which part needs to be milled and how? Next comes assembly, installation of seals, installation of hardware, instructions on how to install the hardware, cutting of rods, and so on. So preparing the assignment for the workshop is also quite a big task, a large document, and accordingly all of this is done by the designer. That is, I pay the designer separately for the KM stage project, separately for the KMD stage project, and for all the material requests. In other words, he gives me a request for profiles, a request for hardware, a request for insulating glass units, and a request for all installation materials. They draw out the brackets, the cover strips, where and which ones, how much insulation I need, foam, styrese, which types, and how many of each kind of dowel, and so on. All of this is specified and illustrated. He even prepares a shipping list for production for me. This is because the materials from Alutech arrive in bulk, and some of these materials are used for the products, while others are needed for installation. For example, self-tapping screws for the clamping strips, self-tapping screws for connecting the post to the crossbar, some rubber gaskets, I'm not sure what else. So a lot of different materials are sent to the site, and you need to provide this information to both the workshop and the warehouse that prepares it for you, because they won't figure it out on their own. They need clear instructions. Here's a pile of materials. From this pile, give these specific materials to the workshop. Here are the drawings, and they'll take care of everything. Then take these products that you've made, add these additional materials to them, gather everything together, pack it up, and a truck will come to pick it all up. That's the only way to avoid mistakes. That's why there's also a document called the shipping documentation, which details everything the workshop needs to send along with the products to the site. And it's the design engineer who prepares this large set of documentation. I believe this is a very important part of the job. We don't skimp on this, we pay our designers well, but it's also a big part of my job to check all of this. So accordingly, I set the technical assignment for the designer, receive the KM project, review it, make corrections, go through every joint, every product. Based on my own experience, I know where and how things are best done. And I make corrections to almost every project. There's no such thing as every project going through perfectly. Now, of course, there are fewer corrections because I already have a kind of symbiosis with my designer, the one I work with, and he clearly understands what I need. But when I turned to other different designers, it was a nightmare, honestly. There could be a huge number of corrections, mistakes, and all sorts of wrong technical solutions. Designers, they don't have that kind of experience. They haven't done installations themselves. They don't deal with this directly, so they might end up doing something incorrectly. Accordingly, I check the KM drawings, then I also review the KMD drawings. I receive the material specifications myself, and I work through all of this directly with Alutech, looking it over, optimizing things like where there are special lengths and so on. I monitor the insulated glass units and work things out with the suppliers. I check to make sure the formula is correct, the coating is right, and the frame color is accurate. I've had mistakes like that too, for example, when the contract specified a black frame, but the designer submitted an order to me with an aluminum frame, and then all the units had to be replaced and so on. In other words, mistakes can crop up anywhere. I've had a lot of them over the course of my career, so to speak. That's why I already know where to look and what to check. I personally control all of this myself, interacting with suppliers, with the designer, with the client, with the architect. We coordinate everything together. This in general is the main part of my job. Then I bring these materials to the workshop. I give the workshop the KMD. The workshop accordingly cuts it all up. The workshop has a ton of questions along the way. How is it there? How is it here? Something is not clear there. Something is not working. The fitters have a ton of questions and so on. So in general, we've prepared the project documentation and handed it all over to the workshop. The workshop made the components, meaning the materials were ordered. The workshop produced the components, and then we arrived at the site. So what do I give to the installers? I give them the project at the KM stage. This serves as their foundation. They do everything according to it. Oh, and one very important point. We introduced something new in the KM project, an installation diagram. This didn't exist before. We introduced this concept of an installation diagram where the openings are actually drawn, the components are marked within them, all installation joints are shown, elevation marks are indicated, and if necessary, references to all axes are provided. If it's not just about centering in the opening, but requires alignment with a design axis, all these references, how to position it, where to take the finished floor level from, are coordinated with the client, specifying from which opening and which mark to use. In other words, the installation diagram is extremely detailed. The brackets are also drawn in because there can be many different types of brackets, and it's not always clear which one goes where. So the brackets are labeled, and the installation diagram shows this bracket goes here, this bracket goes there, and this one goes here. Then there are also supports for the glass units. Sometimes there are a whole bunch of different types on the facade, and it's unclear which support is for which glass unit. So on the installation diagram, we draw all of this as well, indicating where each support goes. In fact, the installation diagram is an incredibly useful document. We introduced it. Yes, it's extra work for the designer and extra pay, but it makes installation so much easier for the installers. He opens the KM working drawings, he has all the components, all the joints, he has the installation diagram, and he understands where to take which measurements, how to set things up from the finished floor, at what height each component should be, where the vertical references are, and so on. He knows exactly where each bracket goes, he has the complete picture, and he can start the installation. Next, he has a KMD for the facade. He's got this pile of bars for the facade. Using the KMD, he understands which post connects to which crossbar, how they are joined, which insert should be used, the type of seal, and so on. He assembles all of this and installs it into the opening according to the installation diagram. He has a shipping list from the workshop and he checks the materials that arrived from the workshop, system components, Alutech parts, whatever was supposed to be delivered. He has a request for installation materials. He checks all the installation materials that have arrived. I'm bringing all of this together to the point of installation. He has a specification request for the insulating glass units. Moreover, the designer doesn't just make a request for the insulating glass units, but also sorts them by crates. And we determine for the house which glass units should go into which crate for convenience, and we distribute them accordingly so that there's no situation like before. I used to have this happen due to inexperience where one crate would have glass units from one facade and another from a different facade on the other side of the house. You see, that's inconvenient. So, when the work is underway, the mini crane is installing, the suction cup is used, and it's just not convenient. You take out one glass unit here, then you have to run over there to install the second one somewhere else. All these unnecessary movements are just very inefficient. That's why all our boxes are organized by facade section. These boxes belong to these particular facades. We distribute them around the site and then the installation takes place. The installers who work with me are sometimes surprised by the set of drawings we provide because for them it's really impressive. There are some who are used to it, and well, there are companies that, like me, also make very detailed drawings. And that's great, respect to them. And there are top-level installers who understand and know what a proper set of drawings should be. But there are also people who install things just like that, using only measurement sheets. And when they see my set of drawings, they're just kind of shocked and say, "We've never seen anything this detailed before." It's so cool and satisfying to do the installation when you have everything you need, when everything is clear to you, when you don't have any questions. Everything is drawn out in the detail. How to install the trim, where to apply foam, where to seal, what to seal with, how to fasten it, which dowel, which anchor to use. And even my list of installation materials, when I submit a request for installation materials, it's often quite extensive with a bunch of different screws, anchors, turbo screws, dowels, and so on. The designer even specifies which screw is for what, which screw goes where, and which dowel is for which part, so that the installer doesn't have to search through the details to figure out which fastener goes where. He even has that information, you see? In other words, he knows exactly what goes where and why. And this is what proper design is all about. If you're interested, I don't mind sharing examples of these documents. So I can just write to me in private messages or in the comments, and I can send you an example of KM, an example of KMD, an example of a set of design documentation, an example of a shipping request for installation materials, and so on. We didn't arrive at this right away. It took a lot of changes, iterations, and experience, and now I realize that, in my opinion, this is the ideal set of documentation that every project should have. I'm not talking about small houses with standard windows. You don't need to do it this way there. In those cases, you can basically just go by the measurements, yes. I'm talking about good large-scale projects where you really need well-thought-out design solutions. And if you have this kind of approach, great, congratulations. That means I'm happy that we have competent companies and contractors. If, on the other hand, your approach is different, I hope this video will help you change something in your work model or business processes and help you realize that without such detailed planning, you won't be able to do things properly. You'll end up with a lot of mistakes and problems. First of all, you'll be wasting your own time. Time is money. You'll be fixing a bunch of mistakes, losing money on buying unnecessary installation materials, wasting installers' time, and paying them extra for downtime. You'll constantly be correcting mistakes. Something wasn't delivered, something wasn't brought, something was assembled incorrectly, something was wired wrong, or something was missing. All of this is a process. Well, I'll be honest, I've been through all of this myself, really. I've experienced it all. And I just try to grow and learn from my mistakes, and I'm trying to pass this experience on to you. And honestly now, when I have a complete set of project documentation like this, both the production team and the installers have almost no questions. Sometimes there aren't any questions at all. Can you imagine? Literally, neither the production team nor the installers have any questions. I have projects that go just like that. It's amazing. It's a real rarity in the aluminum market, I'm telling you seriously. There's always something you didn't account for, something missing, something didn't work out, something you overlooked, and so on. But there are projects, can you imagine? I've even reached the point where sometimes we order the materials, design, manufacture, and install everything. That's it. All I did was organize and oversee these processes, and not a single force majeure happened. Not even a single mistake in production or installation. Everything just went smoothly. I strive to have all my projects go like this. Of course, I understand that this is construction, and there can always be some minor issues. But my goal now is either to do everything perfectly, or to minimize the number of these mistakes as much as possible. And so that these mistakes are so tiny and minimal that they can be solved, say, by quickly going to the store to buy something, or having a courier deliver some materials, or quickly sending something to the workshop to be recut and brought back. In other words, so that everything can be resolved in a single day, instantly. And then it doesn't interfere with your work. You calmly handle these minor force majeure situations. They're not major, so everything goes smoothly for you. You get everything done on time, the client is happy, and so on. Well, this video turned out a bit long, but I hope it was useful for you. Once again, please like the video and help me promote the channel a little. That's it. so that it can be useful for you. Bye everyone.